Good morning, class. In today's lab, we are studying about light. Mainly, we are discussing about refraction and dispersion phenomenon of light. So, main objective of our today's lab is to familiarize with Snell's law of refraction. So, I will discuss first of all what is refraction and what is Snell's law regarding refraction. And second thing is how to calculate refractive index of medium like glass or water or something else, right? That is second thing. So you will know experimental techniques of calculating the refractive index. And finally, we'll discuss about distribution of light. That is called dispersion. Okay. So look at this figure. You can see a pencil in the glass immersed into the liquid. So actually this glass is not broken, but you can see at the interface, the pencil looks like broken, right? Why it is so? This is because of refraction. So based on this figure, you can define refraction as a phenomena of bending of light, right? Because light gets bent when it passes from one medium to another. You know, above this water surface, you can see there is air, right? And after this interface, that is the liquid. The medium is different. The velocity of light decreases when light passes from rarer medium, that is less denser medium, to the denser medium like water, comparison of air and water, right? So look at here. How can we define refractive index? Refractive index is denoted by n and given by a ratio of velocity of light in vacuum to the velocity of light in medium. So this is the definition of refractive index. The refractive index of vacuum is 1. Since the velocity of light decreases when it moves from vacuum to the medium, v will always be less than this v, that is velocity of light in medium, will always be less than velocity of light in vacuum, c, right? That's why value of n will always be greater than 1. Okay, look at this table. The refractive index of air is more than 1, right? 1.000277. It's almost, nearly 1, but it is more than 1. Okay. If you look at the refractive index of water, it is 1.33 for ice. Similarly, you can see 1.31. For glass, you are in today's lab, you are using glass. So refractive index of glass is 1.5. That is the standard value. While calculating percentage error, you have to use standard value of glass as 1.5. That is standard value of refractive index n for glass is 1.5. Look at here. The refractive index of diamond is very high, 2.4. That's why it is sparkle, right? It is shining. Okay. So look at here Snell's law. What is Snell's law? It is the ratio of refractive index of one medium to another medium, and it is related with angle of incident and angle of refraction, right? Right here, this is angle of incident. Suppose there is air and glass medium combination, right? The theta 1 is angle of incident, which is in air, right? And the theta 2 is angle of refraction inside the glass. So right here, N1 and N2 are refractive indices of the medium. That means N1 is a refractive index of air and N2 is refractive index of glass. Okay, this is the Snell's law. So because it gives you the relationship between refractive indices of two medium and angle of incident and angle of refraction. Once you know angle of refraction and angle of incident, you can calculate refractive index, right? Because refractive index of air is almost 1. From previous table, you can look at here, it's almost 1, right? You can take refractive index as 1 and then calculate value of N2. And if, to find value of theta 1 and theta 2, you can do simple geometry. I will explain in next slide, and then you can get refractive index easily. Okay, so look at here. This is the incident ray. For this, you can use laser light, and this is a normal line which is perpendicular to the surface of this glass slab, right? This angle between normal and incident ray, which is called theta 1, is angle of incident. That's what you have to measure, right? And this angle theta 2 inside this glass, after doing experiment, you can remove this glass slide and you can measure this one by using protractor, right? So once you know theta 1 and theta 2, you can calculate refractive index of this glass, okay, this glass slab. Okay, how to do that? First of all, you need these things like glass slab or pins and paper, pencil, like that. And after you get it, what you can do is you can sketch a line, right, like this, exactly like a glass slab, and draw a straight line which represents light rays, and draw perpendicular to the surface of this glass slab. And you can put 2 pins on this line. And remember, these pins should be at least 5 centimeters away from each other. Okay, so when you look at from other side of this glass slide, look at these 2 pins such that they are aligned in a single line, and at that line in which these 2 pins are aligned, you can put 2 other pins like this. Okay, after removing this glass slide, you can join these 2 points to this line, and you can join the points where this line meets to the front line of this glass slab, and you can join this rays from here. Okay, so in this way you can measure angle of incident right here and angle of refraction right here. After drawing this line, you will get an angle here which is angle of refraction. Once you know theta 1 and theta 2, you can calculate n, which is n equal to sine theta 1, that is sine of angle of incident, divided by sine of angle of refraction, right? So now diffraction. What is dispersion? Not diffraction. So dispersion is distribution of light. Okay, because in white light there are different wavelength, different frequency of light are associated, combined together in white light. When white light is passes through the glass prism, or I'm sorry, yes, okay. So when white light is passes through prism like this, the bending of different frequency of light, different wavelength of light will be different. Because of that, you can see different color. Here you can see 7 color of light, right? Ranging from red to violet. So this phenomenon is called dispersion of light. Thank you.